Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through a variety of different topics. Our today's session is the deploying reference architecture. So in this session, we will explore how to deploy a reference architecture build from start to finish, some of the OCI best practices and key topics such as disaster recovery. I'd like to introduce Jason and Lynn as the main presenters. And with that, I will hand it over to Lynn to get us started.
Thank you, Olivia. Today we're going to be covering some basic reference architectures, not just for OCI, though that's going to be the focus. It's really basic reference architectures in the industry today in a lot of respects. The other things just to remind you of is that we have our core series, we have our hands-on series, and a cloud native launchpad, as well as cloud security series. And also, we post what's new in OCI periodically as well. So all these are links that you should be aware of, and Olivia will put them somewhere, I'm sure, uh, as part of this presentation. So what are we going to cover today is Jason and I are going to basically split this. I'm going to go through, really just did, the introduction. We're going to talk about different types of architectures that are in the industry today, and then incorporating some high availability and disaster recovery. Talk to where you can find some of this in the architecture center and the customer scenario processes, as well as some bad patterns and bad and good practices in the process. Jason says he loves the bad patterns.
I always love really bad architecture for learning from the failures of other bad projects.
So let's look at some types of architectures. And this, I noticed most folks here have been in the industry for some time. So this shouldn't be too new to you. At the same time, I think it's a good reference so that we all sitting on the same space when we get started here. So the basic two-tier, this is the original client server architecture. You'd have a presentation tier and a data tier, and the business logic lives in the presentation tier and the data tier in the data tier, or both. So it was it fit where it the software programmer decided it was going to go, quite frankly. And it also depended upon what your presentation layer was. If it was open look on Solaris, it might be different than what it would have been on X on Silicon Graphics at the time. So there was a difference of where the logic would go based upon the software involved. Fortunately, it's no longer 30 years ago, and we pretty much have all come to the standard of web-based HTML for the presentation layer. And then underneath, you have a variety of different choices to make. You can be using Node.js, you can be looking at Java, JavaScript, you can having other processes underneath that actually do the logic. But fundamentally, you have a load balancer, you have your storefront, your media, and your payments. And then, of course, you have your data structure, and we strongly recommend autonomous database at this point, because why interject a DB at this point for uh, additional confusion? Just allow the software programmer to deal with all this appropriately. Notice that in this particular example, we've done a very basic network. We have an internet gateway so that your user can come in and hit the load balancer. We then have a service gateway so that you can get to object store either from your media storefront or from your payments. And of course, you want to be able to get your payments and information directly into your autonomous database. So it says business logic is often limited. It's succinct to the project that's involved. And again, usually a combination of the users involved, marketing, sales, management with respect to where you want things. And then the software programmer does it the way he's most comfortable with. Get it done quick. The three-tier architecture could be a presentation tier as well, an application tier, and then the data tier. This is probably more typical today of most operations. And you see there's not a lot of change there, except the little bit on the links and how you structure them. So it's the benefits here noted is scalability, security, because your back end is in a regional private subnet, and the only way it can get out is through the NAT gateway or through the service gateway and communicating through your autonomous database. Oftentimes you will have a jump server or a bastion if you're in OCI that will let you have access for a limited period of time to those who you want to have access to the software and securities practices behind the scenes with inside this regional subnet. And of course, in this particular case, we're showing our load balancer, our platform as a service load balancer is being used, but that is not a requirement. You could have a virtual machine here with WebLogic. You could have a container with WebLogic and set it up that way. You could have another either container or virtual machine from the load balancer of your choice that's in marketplace. So there's about 7 or 8 different load balancers that are out there. If you're working with something on premise or have worked with something on premise that you're more comfortable with than WebLogic, or want to go ahead and do that instead of using our past service load balancer, we're completely okay with that. The key element is that you're in a safe place. You've structured your access correctly through the internet to your users, and you have your backend servers appropriately configured and in a private subnet for the region. So your in tier, you just add different layers, and just for the sake of complexity. No, of course not. Typically, you don't go to increase your number of tiers unless you're required to go to the number of tiers for specific reasons. For example, in this case, they're actually taking uh, credit card information. And so for security reasons, they put this in a regional private subnet separate from the regional private subnet that they're using for the your storefront and the processing there. And we didn't show it, but you would have another link here to your autonomous database to a separate database in your autonomous database, a container base container database in this situation that you would be utilizing in that location. And the reason for that is because you have credit card information there, and to comply with international standards with respect to that kind of information would require it. So you probably use other tools to further increase your security and comply with those standards. So the idea is that you keep it simple, keep it as simple as you can, but then you have to add tiers based upon the requirements of your application and your standards, right? So cloud native applications, when we talk about cloud native as an industry, we typically talk about infrastructure as a service, but also platform as a service. So in the case that we were talking about discussing now, your load balancer could be a platform as a service. That's our load balancer, where you're using something that Oracle creates and sustains for you in that perspective. The other thing you can look at is looking at the OKE auto scaling. So again, you not only have the load balancer, but you also have Oracle Kubernetes engine monitoring and working with your node pool. Now you could do something similar with virtual machines by auto scaling them, but you can do with OKE is again more considered the cloud native microservice approach, right? So, and think about this as you add to your tiers, as your application gets more complex as well with your autonomous database behind it, you can have different microservices interacting with different types of data. The autonomous database, of course, is an Oracle database, and therefore it not only includes relational data, but it can store spatial data and all the adjacent metadata that's associated with data that's out there now. So you can do not just spatial, but you can look at tools such as document data, JSON, any way that data can be stored, key value, any aspect of that. We are completely comfortable with Mongo and with Postgres style inside our database. So you can use that in a manner in which makes sense to you. And each of the different microservices can communicate with the database appropriate to that service and appropriate to the calls that are necessary. And remember, we support not merely SQL, but the other interaction I mentioned, but we also support Java SDK, of course, but Python SDKs, as well as tools like queuing that are available. And we've added additional features, by the way, for those of you that are using Q to look at what's available in 19C and 21C as well. And 23 AI now that's been released. So the whole idea is you can use what you need and part of this cloud native is about using services as opposed to writing things yourself. So there's always a trade-off. What are you going to pay for? What are you going to write yourself? What are you going to support after you write? So that's another consideration through the whole process. The industry is moving toward writing the very least, spinning up the only what you need to write that makes your particular application distinct. And as also noted in this particular slide, for actually creating it, you can use infrastructure as code or resource manager, which is in fact a queuing system for Terraform. So again, you can deploy, change the deployment, move around very easily with infrastructure as code in this way. Once you get used to it, it's something you have to get used to. And your data tier, as mentioned, is autonomous, which can scale up or down depending upon your requirements. So look at the way from a structural and a cost way. You not only are managing the number of nodes and therefore the number of threads you're utilizing and the amount of memory you're utilizing, but you're also letting the machine measure against your requirements, your use of the data system as well. So best practices, use the regional subgroups, frankly, use the fault domains within the regional subnets to keep your data further secure. Look at and more highly available. Also look at network security groups. Those of you that are familiar with network security groups, it's simply having different firewall rules for each virtual NIC. So you have a set of virtual NICs inside your OKE cluster. Each of those can have different requirements with respect to their firewalls. So those can be organized in the sense of groups. Much easier to manage because security groups apply to virtual NICs, whereas your network security lists that control the entire subnet. And of course, you can manage your CIDR blocks as well and consider your traffic flow and security requirements when designing the subnets and when setting up your security groups. And you attach all the services to a specific tier or role to the same subnet, which can serve as a security boundary at each level. So as you notice, when we were looking at the first multi-tier example, we talked about changing up the subnet depending upon that tier. So
And
let's
Lynn,
look at,
if I can pick on that one last slide, 'cause I just had a conversation this morning on this where we had a customer say, where do I use each one of these layers of firewalls, right? I can install my own firewall right at my border. I can use these network security groups. I can use these security lists. What's an example where we should use each one? It's just a simple example. And the one we rattled off on with this morning's call was, to secure your border, right? Yeah, as Lynn was going through that three-tier design, we had load balancers, we had things facing the internet. When you get to that border of the internet, that's oftentimes when you want to use some sort of firewall service, like our network firewall service, or maybe just a firewall that you're familiar with, like a checkpoint or Apollo that you put an IaaS because you're familiar with it. You want to use those when you want that rich experience, things like logs, things like complex rule sets, right? You want to use things like security lists when it applies to entire subnet. So for example, if you're using some sort of operational tool like Chef for the management of configuration of your environment, and you've got a Chef rule that everything needs to be able to talk to Chef on every subnet, on every VCM, that's a good use case for a security list, right? Security lists apply to subnet layer and everything on that subnet. So when you're doing a broad rule like some sort of monitoring, automation, a pipeline, use a security list. It's very simple. It'll take care of all the resources, both existing and new. And network security groups, as Lynn was alluding to, it applies to that virtual NIC, which means it applies to just that one resource. So if you got something that's a little more obscure, maybe you've got a set of application servers that run on port, I don't know, 5,307, something very unique that wouldn't apply to a subnet. It's not on the border. That's a good case for a network security group, right? I want to attach a single rule to one or a small collection of resources, but I certainly don't want to apply it to an entire subnet. It's probably not something on our border. That's when you use a network security group. So kind of knowing when to use each one of those, as Lynn's going to kind of walk through some of this, it's kind of helps you operationally to follow the best practices to keep it very simple. Go ahead, Lynn. Sorry for butting in there.
No, appreciate it, Jason. So let's look at a particular example just for the sake of anchoring the ideas that we've talked about in abstract to a particular instance. One of those scientifically proven ways to increase your memory of a particular type of training. So we'll look at this MuShop architecture that's been put in place for a MuShop feline food in Vision Corp. So we have it across two availability domains. We have a regional public subnet, a regional private subnet. This looks surprisingly like our two-tier session that we were talking about earlier. The load balancer is talking through the internet gateway to your potential users out here, and you have a NAT gateway for updates to your Oracle Linux here, and you have your access to your object storage through your service gateway. And you could actually have, and that's probably for backup for your autonomous database, but it can also be access to your autonomous database. You could show this as well. So there's different ways to configure that in such a way to maximize your security and to have and limit access to those who don't have need to have access and have access to those who do. As I mentioned, you can also be in a situation where if you needed to have access to that regional private subnet, or you might want to, or to your autonomous database, you might want to use a bastion or commonly known as a jump server in those situations as well. Bastion, I mentioned, is a service that you create and destroy and has a limited period of time, whereas a bastion service, you often have it sitting there all the time for you. Regional public subnet in your virtual cloud network, which is a software defined network. That's all it is to make that work for you. And then you have a regional public subnet, and then that's where you put the load balancer. The regional private subnet, that's where you're going to put the second tier, if you will, and note the different CIDR blocks for each one so that they don't overlap. By the way, /16 is about 65,000, 64,000 something. IP addresses /24 is 256. If you need more, you can control what that slash is. And then as noted, you would have your web servers, the media and storefront, run in either Node.js in this case or HTML5, and then payments. I prefer Fortran, but that's another story. You have your autonomous database in the background, communicate that again through any number of SDKs or through queuing or any other way that you want to do it that makes sense for both your storefront communications and your payments and for your manipulation through there. And so you have an internet gateway so that your users can get there, your NAT gateways, and you do your patching and updates to the operating system of your respective backend servers. And then you also have your object store for saving data and archiving data through your service gateway. So there's a lot of capability here, a lot of security methodology that's built into this location, this approach, I should say. So the full architecture, no real change. And then finally, you can look at cost optimization with networking. We do not, as no one does in the industry and the cloud, we don't care how much data you move in. We're a little jealous about you moving data out. If you use our direct connect, you don't pay for anything in those circumstances for on-premise or back and forth to Azure, but you can be hit with data fees for the 11th terabyte and more for internet egress and cross-region egress in those circumstances. And so you want to leverage the right network service to avoid unnecessary data transfer charges. There's going to be some hits. It costs us. We're just transferring the fees onto you as well.
Working on Lynn. And this topic of cost optimization, we'll get into this with one of the bad anti-patterns. We'll call it a hairpin. I'll dig into why understanding where data egress charges apply and where they don't plays into both architecture. It also plays into where our services, especially our networking services, I think have a little bit more value at times than what you can get with our competitors. All right, guys. So Lynn kind of walked through just some of those high-level architectural patterns of how you build out virtually, I mean, almost any pattern can follow a lot of what he showed. What I'm going to do is I'm going to kind of narrow down to a few more specific things. We're going to talk a little bit about disaster recovery. We're going to talk a little about high availability. And then we'll get to my favorite part of like bad patterns, like things you should not do. And these are bad patterns universally on any cloud. Okay, so we're going to take just a little more of a deep dive here. All right. So OCI commercially is available in multiple regions around the world, right? Some of the more common ones we get into when customers start using OCI is they'll maybe start in our Phoenix region or they'll start in Ashburn, right? Two of the North American areas. But we do have regions all around the world. Many of those regions have the full array of all of our services and multiple availability domains, and we'll talk about that in a second. Some are much smaller, have a smaller footprint, maybe fewer services, but we enable our customers to build virtually anywhere around the world. But when we talk about DR and HA, for today's scenario, we're going to talk mainly about what can we do between Phoenix and Ashburn. Okay? Let's jump into this a little more. So we talked about regions there in the other slide. The other two concepts that are very important for you to understand as you're thinking about your architecture and how you want to host, especially for HA and DR, is availability domains. Now, think of availability domain as nothing more than a data center. If you were to drive to Phoenix or Ashburn, there are 3 data centers in that area, right? You can walk into them. There's power, there's equipment, there's cooling, compute. And in each one of those data centers that we call availability domains, there's this idea that we've compartmentalized it into separate rooms, fault domains. So if you walk into an availability domain, again, data center in Ashburn, it's divided into 3, right? Separate networking, separate power, separate cooling, separate compute, separate storage, separated in 3s within one data center. And we do that so that we have component level failure within one of our availability domains. And in a region, especially the big regions, we have 3 data centers in case there is a major set of component failures impacting an entire AD. Okay, so as you think about this, as you're building out your workloads, you want to think about where practical, especially on new workloads you're building out, new greenfields. How can I build it across fault domains for small component failures? Can I build it across multiple availability domains for major component failures? And do I need it to build it across multiple regions for what's typically going to be like a DR scenario? Okay, we'll come back to some of these concepts as we go through this architecture, both good things you should do and bad things you should avoid. The other thing, and I think of this more of blast radius isolation for your data. we've got this idea of compartments, right? It's a messy diagram, but compartments is nothing more than a logical container to put your resources in. If you're familiar with Azure, this is the idea of resource groups. And it basically comes down to this. If you were to build yourself a server and a network, you can put those servers and networks in the same logical container, the same compartment. And then I can grant a team access to just that server and that network. And then I could build another team, a different server and network, and put it into a different compartment. And then grant a completely different team access to those resources. So I've got two teams, they're hosting their stuff in OCI, they're in different compartments, but I've set up a different set of access so they can't see each other's stuff. Now, why is that important when it comes to HA and DR? It's so one team can't blow the other team up if they do something bad, right? What would happen if someone logged in to the wrong, area and deleted the wrong server, right? If you didn't use compartments, or what would happen if somebody deleted the data, right? The idea of taking your resources and breaking them in different compartments for different teams. Finance should have a compartment. Sales should have a compartment. Your infrastructure guys definitely should have their own compartment. But also the idea of you've got areas that are production, non-production, and sandbox. You should break those out into compartments. And you use this for access. You use this to protect against things getting blown up, like data getting destroyed, environments being accidentally deleted. And you kind of build this in as part of mostly your HA strategy to prevent, good people from doing, unfortunately, dumb things at times or accidental things because they didn't know any better. Okay. So you want to think about your compartments as well as you're, building out your environments and thinking about how to protect them from bad things. Okay. We talked a little bit more networking, right? When you're building out, especially comes to DR, you need to think about connectivity outside your environment, right? In this scenario, I've got an environment that's production in Ashburn. I'm going to build my DR site in Phoenix, right? So I've got kind of that side A, side B for failure. But you got to think about all the connectivity in the event that something bad happens. So in this diagram, we assume we're using the Azure Interconnect because we're multi-cloud, right? We've got workloads in two clouds. I've got a connectivity from my on-premise network through some sort of point of presence, maybe like an Equinix or Digital Realty to get me into OCI to begin with. And then I've got connections from the outside. Maybe I've got like an e-commerce environment, right? As you think about what you need to build out in your DR site, that same external connectivity needs to be wired up as well, right? So you have to have connectivity on premise. You could start with something cheap like a VPN. You don't necessarily have to do fast connects day one to a DR site. Or you could if you want to, make sure that you've got full capacity. If you've got connection to other clouds, you need to build that and so on and so forth. Okay, so it's the idea of as you think about DR, look at all your outside boundaries and your connections, and in your DR site, make sure you account for them and how you're going to have those in some sort of event of bad things happening. Okay. Inside's much simpler, right? We've got this concept of being able to build a remote peering connection, right? So I've got, again, production workload in Ashburn, DR in Phoenix. I got to make sure I build a tunnel for especially my IaaS services to talk. If there's some sort of replication event, this would be where maybe you're using data stage with the Oracle database, and you want to make sure you transfer those, transactions from your primary to your secondary. Okay, so there's a little bit of networking involved between the different regions when it comes to that inside traffic. All right. When you're thinking about DR, sometimes even HA, you got to look at our different replication layers and the different services you're using. So in a three-tiered app, as Lynn was talking about earlier, we've got that front-end web layer. So I've got some web servers. I maybe have an application tier, and I've probably got databases. And each one of those tiers, you may or may not have data that matters, that's important, that you need to replicate. In the database, certainly, there's data going to be that is important. Transactional data for analytics, for e-commerce. And there is a variety of tools you can use to get that data over, whether it's like a ZDM or a data guard or Golden Gate, depending on how much of the data needs to be synced up will help dictate which one of those tools to use. But as you go up your stack, like your application layer, if it has important data, even if it's just the configuration of that server, you might use something like block volume replication, right? If you're building more serverless, think Kubernetes containers. You're probably using a little bit of object storage. You might be using some file storage as well for that shared data access. Again, we've got different data replication services for each one of those layers as well. So you'd build that into your solution as you're thinking about, especially DR, sometimes HA. You'll go through RTO and RPO, and I'm not going to dig too far into this. It's the idea of making sure that you get your requirements and make sure that the replication and the design and the recovery time meets those requirements. You make sure that your solution stack meets one of the more commonly accepted DR approaches, whether it's something like a pilot light or something that's a lot more hot and ready to go, like active-active. Okay. And then this would be an example of where you pull it all together, right? So in this scenario, all right, we're talking about a pilot light DR example. And in a pilot light, what you're trying to achieve is all my data can be replicated to another region. And I've got pretty good recoverability, but I'm trying to save costs to a certain extent. I can't afford like a one-for-one infrastructure where it's just hot and warm sitting there. But I do want to have pretty good recovery. It's basically data light, pilot light in a nutshell. Is I can recover fast, but I'm trying to cost optimize along the way. So in this scenario, we've got a primary database, we've got a standby. You could do it in region, you could do it cross region, works both ways. You've got an app tier, you've got your load balancer tier, you got that classic 3-tier model, right? And in this one, if something bad happens on the left, data guard's going to allow you to recover to that standby on the right. You've got your applications deployed across. In this scenario, we're just talking about in region across at least 2 availability domains, probably multiple fault domains, and you're using our load balancing service, our PaaS service that automatically has failover built in by design. So if something bad happens and we lose everything on the left, you're able to recover to everything on the right. There may be a little bit of scale up that you've got to do, right? Because you're trying to cost optimize, so you got a small footprint, but you've not lost any data. You brought your environment up probably within minutes, maybe as much as an hour, depending on the size. Okay. If we took that same model and said, okay, what if I want to look at this from like an HA standpoint? What does that look like? Well, you're going to use some different tools, right? I talked about earlier, there's multiple different ways to replicate data. And sometimes that depends on whether you're trying to have a DR outcome or an HA outcome. And in this case, if I want no downtime, right? I want to maximize that my environment's up. So I'm not really doing DR, right? I'm trying to achieve the outcome of maximizing uptime, not maximizing how quickly I can come back after everything's down. I always want to be up when I'm talking HA. We'll use tools like Active Data Guard, right? So that our primary cluster and our active standby are almost exactly alike at all times, right? There might be milliseconds of time they're not in sync, but they're close enough that if the side of the left side dies, your right side can like immediately come online and take the full user load. Okay. You'll use tools like TAC. And what TAC does is allows the application servers to have some smarts about the state of the database, right? Is the left side active or is the right side active, right? It takes that burden off the application from knowing which side is the actively, like the read write master for this whole thing. And then TAC's also aware that if there's an event change, right? If you fail over from the primary to the active standby, TAC has got some smarts built in that it is aware and it can switch all the application transactions over to the other side. Again, this is that, how do I maximize the environments up all the time? And so I don't lose any data and I don't have any downtime. Okay, and this is kind of how you work your way through the environment and take those requirements to say, am I trying to achieve some sort of DR outcome, HA outcome, and then how do I build up my layers? How do I use the regions, the availability domains, how do I use the fault domains, and then how do I use, both the infrastructure and the types of replication to make sure that my data is on their side. Okay. So let's talk about, this is my favorite part. Let's talk about bad patterns, right? Things I've seen out in the field, and the customers' names will be nameless, but things I've seen out in the field that are the wrong way of doing things. And then we'll explain why are they bad patterns, okay? Or why are there things inside this pattern that you want to avoid doing? The first one, I'm going to call this too many eggs in one basket. All right. So we talked about on, I think it was slide 25, right? The idea that you have fault domains and you've got regions and that you should split your workloads up. We talked about on slide 26, right? The idea that you want to take your resources and put them in different compartments, right? So let's go back to too many eggs in one basket, okay? When you're building an environment, you do not want to put all your servers, your databases, your storage layers, presentation layers into a single fault domain, or where practical into a single availability domain. Or if I drew this differently, you would not shove everything into a single mega compartment that includes prod, non-prod, and PCI data, non-PCI data, and HIPAA data, non-HIPAA data. You want to make sure you break out your workloads across as many fault domains as you can, as many availability domains as you can, and you want to have a good compartmental design as well that splits out prod from non-prod, and compartments that more than likely split up different work teams, like e-commerce has their own, and finance has their own, right? Why is it bad if you put everything in one spot? If you put all your resources in a single fault domain and we have a small component failure, right? Something minor like lost a switch, and the failover didn't work correctly, and we had a blip on the network. If everything's in one fault domain, there's a likelihood that you might see a same blip or have some downtime, right? Versus if you would have spread your workloads across multiple fault domains. Again, fault domains have separate networking, separate power, separate compute, separate storage. If we had an issue in that one room, your workload probably would have been able to stay up and running because you had it in a different fault domain. Same idea when it comes to availability domain. Now, that's more of a major component failure, right? A component failure that probably cascades and hits other things inside that data center. Where possible, spread your workload out across multiple availability domains, at least two, if not three. So if we have a major component issue, the same idea, you've got your workload in a different AD, and that major component failure more than likely is not going to impact the rest of your workload in AD2 if you've got it spread out across 1 and 2. Now, you may, depending on how long there's an issue, have to scale up your resources in AD2, but the idea is your users, your customers haven't experienced downtime because you spread things out. Okay. Another item, unnecessary hairpins. So Lynn talked a little bit about some of the different gateways that you can use and how that affects where the traffic is routed. Okay, so let's take the two scenarios here. I've got an Oracle database deployed in OCI, got it in my database subnet, it's private, it's secure, and I want to run Power BI reports off that data, right? So now we're going multi-cloud. We're splitting our workload across two different clouds because you want to maybe use the best of the best or what your team is familiar with, so you're going to be using services from both sides. You could run that over a fast connect back to your on-premise environment or a VPN, and then from there get to Azure. But this creates a hairpin. The hairpin is the idea that you've created an unnecessary network connection, a hairpin, and you're kind of bouncing, from one spot right back to another. So in this case, you're bouncing from the cloud to your on-premise environment back to the cloud again, right? Most of the cloud vendors, when we build out our data centers, ADs, zones, availability domains, whatever you want to call them, we build in common locations, oftentimes in the same building, right? So years ago, we actually came out with a network connection called the Azure Interconnect. It was the idea that from the Oracle cage, we just ran fiber over to Microsoft's cage. It's the simplest terms, right? And in doing so, we gave our customers high-speed access, direct access to the Azure cloud. And to avoid this hairpin, in this scenario, what we should have done was made those connections from the Oracle database directly over Azure Connect to Power BI, right? Over that fiber cable I mentioned, just again, basically runs right over between our two cages and doesn't have to hairpin back on premise, adding latency, maybe dropping your bandwidth, adding additional hops, adding additional component failures you have to go over. You want to avoid this, okay? Where possible, directly connect to another cloud using something like the Azure Interconnect, or if all possible, skip trying to hairpin things back through your on-premise environment where practical. Okay. Hairpins can also exist just in OCI. So if we've got an app server here and you want to dump your logs off to something like object storage, that's a good way to cost optimize the cost of storage because object storage is cheaper than block, which was what underpins your web and app servers. You could take your logs and other things that you didn't need to be hot and running and offload the object. You could make an API call out a NAT gateway and hairpin out from the internet back into object and put your logs in that way. But what will be more cost effective is using something called a service gateway. And if you recall from what Lynn was going through, a service gateway is basically just a network component that allows IaaS services mostly, like servers, maybe the Oracle database or other things sitting in your virtual networks to contact PaaS services like object storage, okay? Where practical, you always want to have that connection going from your server to service gateway to object storage and avoid this hairpin of going out of the internet. And potentially in doing so, you pick up some data transfer charges that are unnecessary. Okay, so service gateways are very handy to go from our IaaS services to our PaaS and skipping again the unnecessary hairpins and some additional cost of money. This is from a long time ago. I worked in a team long ago where the strategy for decades with your on-premise environment was strong network controls at your borders, right? You put firewalls at your borders, you put firewalls between your critical systems, you put firewalls to your warehousing, logistics, and manufacturing, you put firewalls around your data, and as long as you had a firewall around that, right, you built these really high network borders, everything was secure. And largely with an on-premise environment, that worked pretty good for several decades. But as you get to the cloud, there's other components you've got to secure, namely your PaaS services, right? So this idea of building firewalls around servers, databases, web, still very solid, right? We talked about that when in the middle of Lens, where we can do firewalls, we can do network security groups, we can use security lists. You should do that. But there's services like object storage that ride on our network, right? The Oracle Cloud Network. They don't actually exist in the network you manage. And so you can't take your firewall or your security list or your network security group and wrap it around something like object storage or resource manager or the monitoring tools because they exist on our network. And the tools you've got to use to secure those PaaS services is basic identity access management, right? Who can access object storage? Over the past many years, if you watch the news, we've got data breaches like on a monthly basis. But the very early ones, still some today, a lot of those data breaches were nothing more than people not understanding that things like object storage could be accessed directly from the internet, directly from your house. And if you didn't lock down your access, your identity access management to that object storage, it didn't matter what you did from a network standpoint, right? If you set your object storage that was publicly accessible, it meant everybody in the internet could access all the data in that object storage. Or if you took your keys or credentials that you used from, say, your containerized app and you published them on GitHub as part of your code, because your code included how to build the environment, how to build the web server, and how to access object storage, that could be easily found by anybody on the internet. And again, they could access your object storage directly, and none of your network, high borders or walls could protect you from people accessing these PaaS services. So with this, things that are inside your VCN, yes, continue to use network borders, use IAM with that. When it comes to your PaaS services, look into deeply on how am I giving access using all my different identity controls, users, groups, dynamic policies, keys, API keys. All these things are things you got to lock down when it comes to the PaaS services. Okay. The avalanche and unique snowflakes. So this kind of brings all several things all together, right? As we talk about, I need to come in and connect to object storage. I need to be able to access a bastion host. I need to be able to dynamically scale up things, right? You've got different environments that have different needs and different groups that need to support them, build things, access them. And as you start working out those access patterns, especially from a network standpoint, you want to standardize as quickly as possible, right? So what is the common pattern for getting into your environment and doing like an SSH or an RDP? How are you going to give people access to sandboxes? And in this one, what we got going on here is we've got some people that they built out a dev staging prod environment all in one container, which is bad. That's the too many eggs in one basket. And because it's convenient, they just built themselves a site-to-site VPN directly from their house right to this network. Now, this is bad, obviously, because now there's no monitoring here. Security doesn't know this exists, and you're only as strong as this person's home network, right? What would have been better is maybe having connect over through the on-premise network so you could monitor it, right? Through probably like a firewall or some IDS and IPS software. On the top here, we've got AI, and AI is everywhere, right? And so everybody wants to run and go as fast as possible to AI. But the same problem, how are you going to let this team access their sandbox environment to do AI? They're probably going to have a bastion host. They're probably using one of our AI ML tools. But then also, how are they getting access to data? And sometimes this data is semi-confidential data they want to play around with. But how do you make sure that this AI team is not building a backdoor into what is your tax and finance production environments? So this is multiple things. It's, do you want them coming in over the internet, or should they be coming into your on-premise network to get to these resources? And these resources, what access do they have? What IAM access do they have to PaaS services like object storage? And what's the data in there? Okay, so you want to standardize and not let everybody just have their own individual ways of coming into your environment and own individual ways of accessing critical data. Come up with a couple standard access patterns, standard ways to give people access, so you don't have these unique little ways of coming in, and one of these is probably going to get in trouble at some point and cause a security issue. You keep going here. Last one, taking a ride in the Titanic. This is a very old idea. It's the idea that whenever we're doing ML and AI and analytics projects, we need data. Oftentimes we've got to move the data around to get there. Sometimes we don't, but oftentimes we've got to build these data pipelines to move data from point A to point B. Sometimes along the way, we've got to clean the data. We might have to enrich the data. We might need to convert ABC into 1, 2, 3. And the right way to do this is what we call a decoupled design. The old way of doing this was just build kind of like a mega monolithic script, right? Extract the data, and when you extract it, clean it, and maybe transform it, and then put it where it's supposed to be. One big script, maybe one tool that did it all. The problem with that approach for years is if anything broke inside your script, like the ABC and 1, 2, 3 logic broke down, the whole pipeline broke. The extract broke, the putting it in the right spot broke, the cleansing broke, everything broke. And it became very hard to troubleshoot when everything was this monolithic scripter tool. With the decoupled design, you would build almost like a microservice, maybe using Kubernetes, maybe using something serverless, where one thing would go and get the data and put it somewhere, and it was done. The next thing might pick it up and cleanse it, put it somewhere, and then it was done, and so on and so forth until each process did its unit of work, was done, put the data somewhere, and once it finally got to whatever your analytics or ML solution was, it needs to pick it up and do the work with it. The reason this is nicer than the monolithic design is if something breaks, right? If your logic and your cleansing and transformation breaks, it doesn't break the rest of your pipeline. You're still collecting data. You're still able to maybe to transform it or cleanse it. You've only broken one spot. It's very easy to troubleshoot. It's very easy to scale. It's very easy to update. So as you're thinking about building out data pipelines to support MLAI, think about how to chunk these up into small pieces into a decoupled design so that you can troubleshoot things when they go bad, modernize them when you want to do something different, and scale them out independently from each other so you don't have just one big mega thing that can break the whole end-to-end pipeline, okay, i.e. sinking the Titanic. Okay. We went over a lot of things today, right? We went over, high-level 2-tier, 3-tier designs. We went over a little bit of HA and DR. We went a little over how to blow things up, bad practices. There's a lot here to remember. Many things we talked about today are going to be in the Oracle Architecture Center, where you can find these designs, proven designs that we've used with our other customers. They'll have things out there like 3-tier architecture. They'll have things out there on how to scale up HADR. They'll have specific designs for very specific apps. Maybe you're running a WebSphere workload or something Java-based or your first Kubernetes environment. The Architecture Center is a great place to find those designs, playbooks, sometimes even the Terraform that comes with them to build out those first sandbox environments you want to experiment with. Okay. We mentioned that. We've got some other resources also beyond the Architecture Center I'd recommend, right? As part of our ongoing training, we've got Oracle University. There's cloud subscriptions. We've got certs like any other cloud platform has. We've also got live labs. If you haven't heard of live labs, it's a great way to get in and play with the environment on maybe an hour, hour and a half. The newer live labs are even better in that it's free. You click on it, it spins up an environment on our dime, so you pay nothing. And when you're done, it destroys it and it disappears. And the thing I'd mention is, as part of the overall Oracle Customer Connect series, we've got more day one and beyond sessions. We've got more advanced topics that take a deeper 300-400 level. So make sure, as you're looking at the different learning sources, keep an eye on Customer Connect because there's a lot of different levels of training out there available throughout the month, going out 2-3 months ahead in advance. Okay. And with that, appreciate everybody's time.
Right. So yeah, maybe since we have a few more minutes, maybe you and Lynn can go over some questions in the chat.
Primary standby, no rack possible. Primary standby. Yeah, let me roll back that slide. I always talk better if I got a picture in front of me. So the question was from Ted. You've got a primary rack, a standby with no rack possible. I'm assuming we're talking about just a primary single node database plus a standby with no rack. Yeah, I believe that's possible. The downside to that, though, is you've lost some level of component failure within one of the availability domains. It definitely achieves the idea that you can cost optimize your environment. I don't necessarily know if I'd want to do that in a production environment or definitely anything that's business critical, because you've also got things like patching that you need to do on these nodes from time to time. You probably even every year, 2-3 years or so, have upgrades. Like a lot of my customers are finishing off doing their 12C to 19C upgrades. It's much easier if you've got at least 3 nodes, 2 in a rack, 1 in a standby, that you can play around with who's primary at any given time for upgrades and especially hot fixing. So yes, technically possible, maybe not recommended for production environments. Okay. Experience building DR environments with MS SQL across OCI regions. Yes, you also can host Microsoft SQL on OCI, and I'll be perfectly honest. You can technically do it, but you're going to miss out on some probably cost advantages of running Microsoft SQL on Azure, just like you would if you ran the Oracle database on AWS or Azure as well. You can do it. I don't know that off the top of my head, the replication technology in place of what you use for data stage. So that might be an area where technically possible. But if you wanted to get into, but what, how do I replicate? How do I recover? Do things like full stack disaster recovery, which is one of our great automation tools. If you're looking at DRHA at all, make sure you look at full stack disaster recovery. That's one of the tools in the industry. I don't know what you'd use for replication and how you'd automate the failover, but that's a good question from your for your Oracle account team, which is a team that I'm on. Whoever covers you, pose that to your ECA. That's something we can dig into and figure out what's the best strategy for failing over Microsoft SQL from one region to another. These are the types of challenges that ECAs we like digging into.
And yeah, thanks everyone for joining today's session.